Welcome to Mr. Rich's Introduction to GPS and GIS Technology. We will be covering both the Global Positioning Systems, commonly referred to as GPS, and the Geographic Information Systems, which we will refer to as GIS. Let us start the discussion with the Global Positioning System. The Global Positioning System is a satellite navigation system that uses a network of satellites to provide precise location information to users on Earth. It's composed of three main parts: the space segment, the control segment, and the user segment. These satellites transmit signals that GPS receivers use to determine their position, velocity, and time. Each GPS satellite has an atomic clock and sends a signal stating its location and the exact time. All GPS satellites transmit at the same instant. The signals move at the speed of light and arrive at a GPS receiver at slightly different times because some satellites are further away than others. The distance to the GPS satellites can be calculated by estimating the amount of time it takes for their signals to reach the receiver. When the receiver estimates the distance to at least 4 GPS satellites, it can calculate its position in latitude, longitude, and height. Global Positioning System satellites transmit signals to GPS receivers on the ground. Receivers require a clear view of the sky, so they are only used outdoors and do not perform well in forests or near tall buildings. A GPS unit is actually a receiver that collects signals from satellites such as your cell phone. Here are 4 examples of how GPS is used in various applications. We will cover navigation, tracking, mapping, and precise timing. GPS is used for navigation in vehicles. This includes cars, trucks, and airplanes to provide directions and route guidance. GPS is used to track people, pets, and things of value. GPS trackers can monitor the movement of objects, people, or vehicles, such as in fleet management, personal safety, and even pet tracking. GPS data is used to create maps. Constant feedback from GPS devices is used to update existing maps with accurate location data. GPS is used to synchronize clocks in various systems. GPS provides incredibly accurate time for telecommunications networks, banking systems, and financial markets. Next, we will cover the Geographic Information System. GIS, short for Geographic Information System, is a system that uses computer software to gather, manage, analyze, and visualize geographically referenced data. It essentially combines maps with other information, like demographic data, environmental data, or infrastructure details, to reveal spatial relationships and patterns. This allows users to see how different datasets relate to each other based on their location, helping them make informed decisions and solve problems. GIS fundamentally relies on 4 key components: data, hardware, software, and people. These elements work together to capture, store, analyze, and visualize spatial information. Here's a more detailed look at each. GIS operates on geospatial data. Geospatial data, which can include information about where things are located on Earth's surface. This data can be collected through various methods, including satellite imagery, aerial photography, GPS, and scanned maps. GIS systems require some fairly common hardware to run. This typically includes computers, GPS devices, and hardware for outputting results like printers and monitors. GIS software is required for managing, analyzing, and visualizing spatial data. This software provides tools for data entry, editing, analysis, and mapping. GIS requires trained individuals for maintaining the GIS systems. They are responsible for data collection, analysis, interpretation, and communicating the results to others. Here are 5 examples of GIS. These will cover urban planning, disaster management, agriculture, healthcare, and environmental monitoring. GIS helps with urban planning. Cities can use GIS to manage growth, plan infrastructure, improve public services, analyze population demographics, predict future development patterns, and optimize transportation routes. GIS is a valuable tool in disaster management. It enables quick response to natural disasters like earthquakes, floods, and wildfires. It helps identify vulnerable areas, assess damage, and coordinate relief efforts. GIS is used to optimize agricultural practices. Farmers can use GIS to manage resources and monitor crop yields. It helps identify optimal planting locations, monitor soil conditions, and manage irrigation systems. GIS helps medical professionals track healthcare. They can use GIS to monitor the spread of diseases, identify areas with high risk, and improve healthcare delivery. It can be used to map disease outbreaks, identify vulnerable populations, and optimize healthcare resource allocation. GIS is used to monitor changes to the environment. GIS can track changes in pollution levels and track wildlife populations. It can also track deforestation, map air and water quality, and identify areas at risk from environmental degradation. In conclusion, we have delved into the world of GPS and GIS, two technologies that are transforming how we understand and interact with our environment. From personal navigation to large-scale spatial analysis, these tools provide powerful capabilities. But ultimately, it is not just about the technology itself. It's about the insights and decisions that these tools enable us to make. By understanding GPS and GIS, we can approach problems with greater accuracy and efficiency, leading to more informed and effective solutions. Thank you all for your attention during today's lecture with Mr. Rich on GPS and GIS. I hope you found the information helpful and insightful.